Hi, so there is a query to describe the double slit experiment of quantum physics in simple terms. So before going to the quantum part of it, I would like to take the classical physics example and then we move to the quantum objects. So if you take a board, for example, having two slits, and you make two slits in it, slit 1, slit 2, and behind that you keep some kind of a screen, and then you take a tennis ball which is wet, and you throw the ball from the first slit which hits the screen behind the board, and there's a mark which will be there because the ball is wet. You will be able to see the mark at a certain place on the screen. If you close the slit 1, you open the slit 2, and then again throw the tennis ball, there's going to be a mark at a different place on the screen behind the board, and you can take another ball like a rubber ball or a table tennis ball or anything, and you'll see the same behavior which is happening. If you open both the slits and then you throw tennis balls, then you'll be able to see the marks which are happening on the screen behind the board, and you can see where it is hitting. There's going to be a mark. Where the next ball is hitting, there's going to be a mark. So that's the behavior of classical physics. We know what is going to be the trajectory of the object, where it is going to hit, and we can see the mark on the screen, as I said, right? When you throw the balls from both the screens, as well as when you throw the ball from one slit or the other slit, and when you throw the ball from both the slits. Now we move to the quantum objects like electrons and photons, the quantum particles, and you take an electron gun and you fire the electron gun and you close the second slit. The electrons are going to travel through the slit 1, going to hit the photo screen behind the board. Yes, you see a behavior similar to classical physics, where it is going to hit, there is going to be a mark on the photo screen, and you know, okay, it's behaving like a particle. Right? Electron is behaving like a particle, a photon is behaving like a particle. You close the slit 1, you fire through the slit 2, and you will see the similar behavior, only the place is going to be different. The electron is going to hit at a different place on the screen, but you will see the particle behavior. So yes, you will see the similar behavior to what is happening with the classical physics when you take a ball into the experiment. So then you open both the slits and you fire the electrons travel through both the slits, and you expect to see the same behavior as you saw with the balls, but it doesn't happen that way. You see an interference pattern, which is amazing, because so far we saw that the electrons or the photons were behaving like particles when it traveled through slit 1 or through slit 2. But when you open both the slits simultaneously, you see a wave kind of behavior. There's going to be an interference, like you see in a lake or a river when you see both the waves interfering with each other, and then you see the crest and crest adding, and the amplitude increasing, trough and trough adding, and the amplitude increasing, and where a crest and trough comes, then they neutralize each other, right? So you see that kind of behavior happening when you open both the slits. So that was something very perplexing, very amazing to see what is happening. So what the scientists did to understand what is really happening, they put two detectors behind both the slits to see what is really happening. Because even when you take a single electron, instead of firing electrons after electrons, you fire electron, then you wait for some time, and then you fire the second electron, you let the first electron go, then waiting after some time you fire the second electron, you see the similar behavior. So even when a single electron is going, you see the interference pattern on the screen behind, which is absolutely puzzling, because there are not even two electrons which are traveling and interfering with each other. It's a single electron going, and there's an interference pattern which is happening on the screen. So this was like a wave-like behavior, where it is expected that the electron is traveling through both the slits at the same time, and because it's a wave, the interference pattern is being seen on the screen. So to understand what is really happening, why it's behaving like a particle when the one slit is open, why it's behaving like a wave when both the slits are open, scientists put detectors behind both the slits to see what is happening. And when you put detectors behind both the slits, what you see is what you expected in the first place. The interference pattern disappears, it goes away. And you see the behavior which was there with the balls. You see the particle-like behavior, the one electron traveling from one slit, you see a mark on the screen, another electron traveling through slit 2, and you see another mark on the screen like a particle, right? Not an interference pattern. The pattern goes away. The wave-like pattern goes away. It starts behaving like a particle. So you take off the detectors to see what happened, and again you see the interference pattern. So nature is not allowing us to see what is really happening. When you put the detectors to observe what is happening, you see a very different behavior. And when you take off the detectors, you see a very different behavior. So this is called the wave-particle duality of the quantum particles. And Richard Feynman, I think, once called them as wavicles because they are behaving like wave also and particles also. So that is something which is very puzzling or perplexing. That's why the double slit experiment is something very interesting and very intriguing. And we hope, like with the speed at which AI is growing, and maybe in future we will be able to, utilizing artificial intelligence, we may be able to crack what is really happening, or it is possible that the nature will not allow us to uncover what it's really doing. Thank you.